Have you ever wondered what everything around you is really made of? Not just your phone, not just your body, but everything, from the air you breathe to the stars in the sky. For a long time, scientists believed atoms were the smallest building blocks of the universe, tiny, indivisible, the final layer of reality. But then, something surprising happened. Scientists looked deeper. Inside the atom, they discovered even smaller particles, protons, neutrons, and electrons. It felt like they had reached the end of the road, but they hadn't. Because inside protons and neutrons, there was something even more fundamental, something almost impossible to imagine. They are called quarks. Quarks are unbelievably small. If an atom were the size of a football stadium, a quark would be smaller than a grain of sand. And yet, these tiny particles build everything you see around you. But here's the strange part. Quarks don't behave like normal particles. They come in different flavors, up, down, charm, strange, top and bottom. And no matter what scientists do, quarks are never found alone. They always stay together, locked inside particles like protons and neutrons. It's as if an invisible force is holding them, refusing to let them separate. So now the question is, what is this force? And why can't a quark ever exist on its own? That's where the real mystery begins. We zoom inside a proton and finally see how quarks live together. Imagine shrinking yourself again, smaller than an atom, smaller than the nucleus, until you reach a proton. At first, it might look like a tiny solid particle, but it's not. A proton is actually made of 3 quarks, 2 up quarks and 1 down quark. These names might sound simple, but they represent something very deep. They are different types of quarks, with different properties, different charges, different behaviors. And when these 3 quarks come together, they form a proton. But here's where things get interesting. These quarks are not sitting still. They are constantly moving, vibrating and interacting with each other in a chaotic dance. And holding them together is an incredibly powerful force, a force so strong that nothing in the universe can easily break it. This force is called the strong force. And this force is carried by tiny particles known as gluons. Think of gluons like invisible threads, constantly passing between quarks, binding them together. Without these gluons, the quarks would fly apart, and if that happened, protons wouldn't exist. Atoms wouldn't exist, matter itself wouldn't exist. But here's the most unbelievable part. Even if you try to pull quarks apart, they don't separate. Something even stranger happens. The harder you try to separate quarks, the stronger the force becomes. It sounds impossible, but it's true. This force, the strong force, doesn't weaken with distance like gravity does. Instead, it gets stronger. Imagine stretching a rubber band. The more you pull, the more tension builds. Now imagine a rubber band that never breaks. That's what it's like between quarks. The more you try to pull them apart, the more energy you put in, the stronger the connection becomes. And then something incredible happens. Instead of separating the quarks, that energy transforms into matter. A new pair of quarks suddenly appears. It's like the universe is saying, you're not allowed to isolate a quark. This phenomenon is called quark confinement. No matter what we do, a single quark can never exist on its own. Only in groups 2 or 3 always bound together. Sometimes they form pairs called mesons, 1 quark and 1 antiquark. Yes, antiquarks. Every quark has an opposite partner. Same mass, but opposite charge. And when a quark meets its antiquark, they destroy each other in a flash of pure energy. Matter turning into energy right before our eyes. But this raises an even bigger question. Where did all these quarks come from in the first place? To find the answer, we have to go back to the very beginning of the universe. Back 13.8 billion years, to the moment everything began, the Big Bang. In the very first fraction of a second, the universe was unimaginably hot. So hot that nothing could hold together. Not atoms, not protons, not even neutrons. Only energy and tiny particles moving at extreme speeds. Among them were quarks, but they weren't bound together like they are today. They existed freely, in a chaotic state called quark-gluon plasma, a kind of cosmic soup. Quarks and gluons, floating freely, colliding constantly and with no structure at all. No atoms, no matter, just pure raw energy. But then the universe began to expand. And as it expanded, it started to cool down. Slowly, step by step, things began to change. Quarks started to come together. They combined, forming protons and neutrons, and those particles became the building blocks of atoms. Atoms formed gases, gases formed stars, stars formed galaxies, and eventually planets. And on one of those planets, life began. Everything you see today started from that moment. Every atom in your body contains quarks that were born in the early universe. Ancient, timeless, still existing inside you right now. But even today, scientists are still trying to understand them completely. So how do we study something that we can never actually see? We can't hold a quark. We can't photograph it. We can't isolate it. And yet, we know it exists. How? Because of evidence. Clues left behind in powerful experiments. To study quarks, scientists use massive machines called particle accelerators. These are some of the most advanced machines ever built by humans. And the most famous one is the Large Hadron Collider. It's located deep underground, stretching for 27 kilometers. Inside this Vishal ring, particles are accelerated to speeds close to the speed of light, faster and faster, until they carry enormous energy and then they collide. When these particles smash into each other, it's like recreating a tiny version of the Big Bang. For a fraction of a second, the particles break apart, and the quarks inside them reveal their presence, not directly, but through the patterns they leave behind. It's like seeing footprints in the sand. You don't see the person, but you know someone was there. Detectors surrounding the collision point record everything. Every particle, every direction, every burst of energy. And from this data, scientists reconstruct what happened, step by step, like solving a cosmic puzzle. Through these experiments, we've discovered different types of quarks. We've measured their properties. We've confirmed the existence of gluons, the particles that carry the strong force. And we've even discovered entirely new particles, all from these high-energy collisions. But here's the truth. The more we learn, the more questions we find. Why do quarks have the masses they do? Why are there exactly 6 flavors? Why does the strong force behave so differently from other forces? Even with all our technology, quarks remain mysterious, hidden deep within matter, never directly seen, only understood through their effects. And maybe that's what makes them so fascinating, because just when we think we understand the universe, it reminds us, and there's always something deeper. Quarks are more than just tiny particles. They are the foundation of everything. Without quarks, there would be no protons, no neutrons, and no atoms. No matter, no stars, no planets, no life. Nothing we know would exist. And yet, we cannot see them directly. We only know they are there because of the subtle clues they leave behind. They remind us that reality is layered. What we see and what we touch as what we consider solid is just the surface. Beneath it lies a hidden world, a world ruled by quarks, gluon, and the fundamental forces of nature. These forces are unimaginably strong, but yet invisible. They hold the universe together, shape every particle, and determine the very structure of reality itself. Quarks are ancient. Some of them have existed since the first moments of the universe. Inside your own body, inside every atom, there are quarks that have traveled billions of years on surviving supernovas, galaxies, and cosmic events to be here now. And even today, scientists continue to study them, pushing the limits of knowledge, probing the boundaries of the very small, trying to understand the building blocks of existence. One day, we may discover something even more fundamental than quarks, something deeper, more mysterious, more powerful. But for now, quarks remain one of the greatest secrets of the universe, tiny, invisible, unseen, yet the most powerful and essential components of everything that exists. Quarks, the building blocks of reality itself. The story of the universe begins and ends with them.